Welcome to our class. This is a circle. The center of the circle is the origin. So we have the coordinates 0, 0. If I say that the radius of this circle is 1 unit, then you have a radius that is 1 here. Then from 0, 0, you move to the right, then you will have a point of intersection of the circle and the x-axis. We have the coordinates 1, 0. That's positive because you're moving to the right. However, if you would like to get the coordinates of the point of intersection of the circle and this x-axis here, as you move to the left, then you have -1, 0. Now, from the center, you move 1 unit upward. The coordinates of the point of intersection of the circle and the y-axis are 0, 1. And if you move here downward, the coordinates of the point of intersection of the circle and the y-axis are 0 and -1. But circle is a collection of points. So look at this. From the center of the circle to a point here, and that is 1 unit. Imagine that you are rotating it. So it means to say circle is a collection of points as you try to rotate the length of the radius. Now, a circle with radius that is equal to 1 has an equation x squared plus y squared is equal to 1. The equation x squared plus y squared is equal to 1 illustrates what we call a unit circle. Unit circle is a circle whose radius is equal to 1 unit. And because circle is a collection of points, then I can select any point found on the circle. Okay? If I have a point here, this found on the circle, I name this point as point P. And the center of the circle, I will name it as point O. Then this point P has coordinates x and y. And remember, the coordinates of point P are found on the circle. Okay? So it means to say, if I square the x coordinate and add it to the square of y coordinate, will give me 1. And remember that when I connect point O to point P, this illustrates a radius. Still, the length is 1. Okay? Now, from point P, I am going to draw an imaginary vertical line that is perpendicular to the x-axis. That is perpendicular, okay? I will name it the point of intersection of the x-axis and the one I just drawn, imaginary vertical line, is point M. And notice, I was able to create a triangle. Now, how do we illustrate the coordinates of point P with regards to the unit circle? Remember that a while ago, I created point M, and this point M is the point of intersection of the x-axis and the imaginary vertical line. That is why we have a right triangle here. This x-coordinate represents the length or the distance of point M to O, or OM, length OM. Now this y-coordinate of point P here represents the distance of point P to M, that is y. So meaning to say, x here is the distance of OM and y here is the distance of P to M.
This is an animation illustrating the changes happening to point A as it moves from quadrant 1 to quadrant 4, recognizing the signs positive for quadrant 1, negative positive for quadrant 2, negative negative for quadrant 3, and you also have positive negative for quadrant 4, and you also observe here changes on the angles. These two, alpha here in green and beta in white, illustrates one complete rotation. Okay, we also observe the changes on alpha and beta, and when you add the measures of these two will form one complete revolution. Also observing the changes happening to x here, you see it moves to 0 and suddenly it increases, but it's only limited to 1. And so with y, it increases but it's only limited to 1. So that is how we illustrate the unit circle. Now all points are gathered.
Now, x squared plus y squared is equal to 1 can still be derived using the definition of right triangles. Remember that OP here is the hypotenuse already. OM and PM are the sides of a right triangle. Therefore, using the definition of the Pythagorean theorem, we know that the square of the hypotenuse OP is equal to the sum of the squares of the two sides OM plus the square of another side PM here. The square of OP, or the length of OP, is represented by R, but R is equal to 1. So you have 1 here. OM, the length of OM is being represented by X. So you have X and square. And PM is represented by Y. So B squared, Y. Still we have the same. This is the equation of that unit circle. I will name this point having coordinates 1, 0. I will name it as point C. So I have line segment OC. This OC can represent an initial side, and OP can act as the terminal side. So it means to say that there is an angle being formed, and that is being represented by theta. Because there is a movement from OC, then it moves. So from OC being the initial side, it moves counterclockwise and it stops at point P. So we have line segment OP here. So automatically there is a generated angle, theta. And because there is a generated angle measurement here, you expect therefore that there is an intersected arc. There is a particular arc length here. Okay? And because the radius, take note that the formula in getting the arc length S is equal to radius times theta. And because the radius is just 1, then we say arc length is equal to theta. But getting the sign of this theta here, we need to recognize the opposite side and the radius, or the adjacent side. So we have sine theta is equal to the opposite side, that is y, over the hypotenuse, which is r. And remember that r is 1. So you can just place it y over 1. So it means to say sine theta of a unit circle is simply y. So what is the implication of the cosine and that of sine? Well, it means to say therefore that the coordinates of point P, which are x and y, can now be represented using cosine and sine. And that is already found here. So meaning to say, point P, we can now change x into cosine. And that will be cosine of theta, and this y here will become sine This will represent the coordinates of any point found on the unit circle. Now, how do we find the coordinates, the real number value of the coordinates of any point on the unit circle? Remember that we were able to form a triangle here. Let us now talk about the special right triangles. And these are the 30 degrees, 60 degree, 90 degree right triangle, and the 45 degree, 90 degree right triangle. From these two, we can able to generate the special right triangles, the coordinates of any point on the unit circle. Let us try to illustrate the 30, 60, 90 degree right triangle. But imagine this one. From this triangle PMO, I will extend another side here. So this one, consider this one as T, and this is point M, and this is O. Okay? This angle, and so if the radius is 1, then I can say this is also 1. This is also 1. Okay? Now, if I assume that this theta here is 60 degrees, so this will be 60 degrees. And by the rule, if the opposite side of this angle, 60 degree angle, is 1, and this is 1 also, its opposite angle must have a measurement of 60 degrees also by the rule. Okay? Now this point P here, point P connecting the point M, so we have what we call a perpendicular bisector. So it means to say, if this is 60 degrees also, because 60 plus 60 plus 60 will give us 180, and that is the sum of the interior angles of a right triangle. Okay? Now half of this will give us 30 degrees, and this is a right triangle that is being formed. Now we have the 30 degree, 60 degree, 90 degree right triangle here. Okay? Now, if this is 30 degrees, which is originally 60 degrees to form a triangle, now we are just interested in the triangle PMO here. So we have triangle PMO. The length of the side, that is hypotenuse, is still 1. OM is 30 degrees, and the length of OM is now 1/2. So what is the length of this? What is the length of PM? Side PM. We will find it using the rule of Pythagorean theorem. Okay? So it means to say C squared is equal to A squared plus B squared. C is 1 here, square 1. So A or B, you can take any of this side here. Let's say B is unknown, so A is 1/2, so square 1/2. So B squared is equal to 1 minus the square of 1/2, and that is 1/4. So B is equal to the square root of 1 minus 1/4 is equal to 3/4. 4 is a perfect square number, okay? And 3 is not a perfect square number, so B is equal to square root of 3 over 2. The measure of PM, or the length of PM, the length of PM is the square root of 3 over 2. So how do we understand this? The side opposite 30 degree angle will always be 1/2. And the side opposite 60 degree angle will always be square root of 3 over 2. And the radius is always 1. And that is the definition of unit circle in the 30 degree, 60 degree, 90 degree right triangle. So it means that if this theta is 60 degrees, this is 60 degrees, and looking here, the adjacent side for 60 degrees is 1/2, so it means to say this must be 1/2. And this will be square root of 3 over 2, meaning to say a point that is, generates an angle that is 60 degrees, can have a coordinates on the unit circle. Its coordinates are 1/2 and square root of 3/2. That is already the implication if theta here is 60 degrees. However, if theta here is 30 degrees, so it means to say the side opposite, as illustrated here, the side opposite 30 degrees must be 1/2. So this must be 1/2. However, the other is the square root of 3/2. So the coordinates must be x square root of 3/2 and y is 1/2. Okay? But if, so in the idea of unit circle, and with reference to this derivation here, we can say therefore that if we would like to get sine 60 degrees of this triangle here, and according to the definition, sine theta is already equal to y, which is also true because the radius is just 1 or the hypotenuse is just 1. So the opposite side of 60 degrees has a length of square root of 3/2 divided by 1, so itself square root of 3/2. So immediately you know already that sine 30 degrees is the square root of 3/2. Okay? So cosine 60 degrees, adjacent side is 1/2, so that is immediately 1/2. However, if our reference is 30 degrees now, not 60 degrees, then we can have this also. Cosine 30 degrees. So the reference is 30 degrees here, and cosine adjacent side, and that is the square root of 3/2. And for sine 30 degrees, reference 30 degrees, sine 30 degrees is equal to the opposite side, 1/2. So that is the meaning. That is the implication of the 30 degree, 60 degree, 90 degree angle in the units. Okay, the next special right triangle is the 45 degree, 90 degree angle. So let us assume that theta here is 45 degrees. So we have triangle PMO here. So I will illustrate that here. Triangle PMO with the idea that still the radius is 1. Our assumption here is, what if this is a 45 degree angle? So angle O has a measure 45 degrees. This is 90 degrees. So automatically, this is also 45 degrees to complete 180 degrees. Okay? We call this triangle as isosceles right triangle because the two sides are equal. Meaning to say, since we have 45 degrees and we also have 45 degrees here, and we let this one as x, this also must be x since we don't know the measurement. Okay, now using the rule of Pythagorean theorem, we can now find the measure of x. So the square of the hypotenuse, that is 1, square 1, is equal to the sum of the squares of the two sides. Square the first side since they are just the same. So x squared plus x squared. Okay, square 1, that is simply 1. So x squared plus x squared is 2x squared. Okay? Divide both sides by 2. We now have x squared is equal to 1/2. Get the square root of both sides, so we can cancel out square there. Okay? So x is equal to the square root of 1/2. And 1 is a perfect square number, so we have x is equal to 1 over square root of 2, following the rule of radical numbers or the rule of exponents. Rationalizing 1 over square root of 2, multiply that to square root of 2 over square root of 2. Okay, so x is now equal to square root of 2 times square root of 2 is simply 2. And 1 times square root of 2 is square root of 2. So x is equal to square root of 2 over 2. So this will now be square root of 2 over 2. And so with the other, square root of 2. So what is the implication of this? Now we observe this. This is 45 degrees, the other is also 45 degrees. They have the same length because that is an isosceles right triangle. So it means to say, if I get cosine 45 degrees, cosine. So I can just choose any of these two reference angles now. Why? Because they're just the same. And the answer is simply square root of 2 over 2. So can we say that cosine 45 degrees is also equal to sine 45 degrees? Let us observe. So if I use this as the reference angle, the opposite is still square root of 2 over 2, then they are just the same. Okay? So we have sine 45 degrees is equal to square root of 2 over 2 also. Observe that this is 45 degrees, and what if we are going to use radian measures? Going back to the illustration a while ago, we say that S, or the arc length, is equal to theta here, and theta must be a radian measure. However, since the radius is 1, it does not give any effect in the arc length. So the radian measure representing theta is also the arc length. And what is the implication? We know that 60 degrees can be transformed or expressed in radian measure, and that is 60 degrees. When you multiply that to pi over 180 degrees, or radians now, will give us, we cancel 0, and 18 and 6 are both divisible by 6, so we have 3 now left here, right? So we have pi over 3. So the implication, since arc length S is also theta, and theta here is automatically represented in the radian. So the radian measurement of a degree measure is now the arc length, or will also be the radian measure. So the implication is 60 degrees, that is pi over 3. Sine 30 degrees is also equal to sine pi over 3. That is the implication. Cosine 60 degrees, which is 1/2, is also equal to cosine pi over 3. Now, 30 degrees in radian measure is pi over 6. So cosine 30 degrees, which is square root of 3 over 2, is also equal to cosine pi over 6. And in here, sine pi over 6. And since 45 degrees is equal to pi over 4, okay, then we say that cosine 45 degrees, which is equal to square root of 2 over 2, is also equal to cosine pi over 4. Sine 45 degrees is equal to sine pi over 4. So you see, even if you have the radian measure, but always remember that the calculator must be in radian measure if you would like to solve it using your calculator. Okay, I will teach you how. So if this is 45 degrees, okay, so the other must also be 45 degrees. The side opposite 45 degrees here, we know that that is the square root of 2 over 2. We just solved it, okay? The other is also square root of 2 over 2. So the coordinates of a point that forms or generated 45 degrees as it moves counterclockwise must have coordinates square root of 2 over 2 and square root of 2 over 2. That is the implication. Remember again that we have triangle PMO here. That the hypotenuse is R, and this X here represents OM, and Y represents PM here. Okay? Now we can solve the other trigonometric functions using the idea of right triangles and trigonometric ratios as well. So from this illustration, where R is the hypotenuse, we say that cosine theta is equal to the adjacent side x, that is x over r, okay? Which is equal to x, because r is simply 1. And the reciprocal of cosine theta is secant theta. So secant theta will now be r over x, which is simply 1 over x. Okay? Next is sine theta, and that is theta here. The opposite is y, so we have y over r, and r is 1, so we have y. And the reciprocal of sine theta is cos secant theta. And that will be r over y. And r is 1, so we have 1 over y. So tangent theta is equal to the opposite side y over x, the adjacent side, okay? So its reciprocal cotangent theta is simply x over y. From this definition, we would like to get the trigonometric values given cosine and sine that we just solved using the special right triangles. So in the idea of the 6 trigonometric ratios, because we form a right triangle here and we solved already sine, cosine, these are just basic trigonometric values. No? What if you are asked to solve tangent 30 degrees? Now tangent 30 degrees, looking here, 30 degrees as the reference, and the opposite is 1/2. So we have 1/2. So that is the representation of x in the illustration here. Okay? So the adjacent side is square root of 3 over 2. So since you observe 2 and 2 here, you can just cancel it out. And that is 1 over square root of 3. Rationalizing that will give you square root of 3 over 3. And that is tangent 30 degrees. Okay? So what if you are asked to solve secant 60 degrees? So still you can have in your mind that secant is the reciprocal of cosine. So that is 60 degrees, so you have cosine 60 degrees here. Okay? So that is 1 over cosine 60 degrees. And since cosine 60 degrees is 1/2, so we have 1 over 1/2. Getting the reciprocal of 1/2, and that is 2. The answer for secant 60 degrees is 2. So this point here can also be a representation of a terminal point. Okay? If I say this is point A, so it has coordinates 0, 1. So how do we identify its measure, the angle measure? That is 90 degrees. Okay? So it means to say cosine 90 degrees is simply the x coordinate of that point A, that is 0. So cosine 90 degrees is 0. So what about sine 90 degrees? 90 degrees, the x coordinate is for the cosine. Now the y coordinate is for sine. The answer is 1. So for example, you would like to get tangent. So what about tangent 90 degrees? Tangent 90 degrees is equal to the reciprocal. And tangent 90 degrees is y, okay, over x. Y is 1, x is 0, but since 0 is the denominator, it cannot be, right? So tangent 90 degrees is not defined, so that is undefined. Cannot happen. We have over 0 as denominator. So what about if you are asked to solve what is cotangent 90 degrees? Cotangent 90 degrees will now be x over y. X is 0, x coordinate is 0, and y is 1. So 0 divided by 1 is 0. Okay? So the reciprocal of cosine, we have secant 90 degrees. So if cosine 90 degrees is 0, then secant 90 degrees will form this way. So it cannot be, right? So secant 90 degrees is undefined. So what about the reciprocal of sine 90 degrees? The reciprocal of sine 90 degrees is cosecant 90 degrees. So 1, or reciprocal of 1 is 1 itself, right? So cosecant 90 degrees is 1. So if you have an angle in its standard position, so it moves counterclockwise and you stop here. So that is a representation of 180 degrees, okay? Now the coordinates of the points, a point of intersection of the unit circle in the terminal side, and that is -1, 0. So it means to say from negative 1, 0, cosine 180 degrees is negative 1. Okay? And sine 180 degrees is simply 0. So if the movement is clockwise, so here in standard position you move this way, so you stop here, that is negative 90 degrees. Okay? The coordinates are 0, negative 1. It means therefore cosine negative 90 degrees is the x coordinate, that is 0. So we have 0. And sine negative 90 degrees, the y coordinate is negative 1. So it follows. So if you would like to get cotangent negative 90 degrees, cotangent is x over y. X is 0 divided by y, that is negative 1. The answer is 0. Or if you would like to get the reciprocal of cosine negative 90 degrees, and that is secant negative 90 degrees. If that is 0, reciprocal 1 over 0, it cannot be, right? So that is undefined. So reciprocal of sine, you have cosecant negative 90 degrees. That is negative 1, reciprocal of negative 1 is itself negative 1. So for cotangent, if cotangent negative 90 degrees is 0, then tangent negative 90 degrees is undefined.
Summary of the positive angle measures, but again, I would like to emphasize that it is infinite rotation, okay? So it keeps on going back to these measures, and recognize again the counterclockwise rotation to have positive angles, okay? All in standard position. Negative angle measures can be derived if we have clockwise rotation as well, okay? Now, you see, you must be very cautious on the negative signs and also the positive signs, because these will be involved, as we go through, especially on the trigonometric identities. So here we are illustrating the degree measures and the radian measures on the unit circle. And since the radius is 1, again, it will always happen that the radian measure is also the same with the angle measure, okay? That recognizing angles in standard position always. Now these are the points on the coordinate plane, illustrating 30 degrees, so it moves to 45 degrees. All positive angles are generated when the rotation is counterclockwise, okay? But if you rotate it clockwise, then it's a reverse. So here we have negative 90 degrees, you have in here, then it goes here negative 180. Okay, but the quadrants are not changing. This remains to be quadrant 1, quadrant 2, 3, and 4. And all signs are not changing, just that recognizing negative angles because of clockwise rotation. So in here, we also recognize the points on the unit circle. But at this time, we are now using the reference angles. So you have 30 degrees here. The other 150 degrees also makes use of the property of 30 degrees, that it has coordinates. A point having 30 degrees generated angle has coordinates square root of 3 over 2 and 1/2, but it only changes sign because the point already is found on quadrant 2. Okay, so you see this is already a summary of the values. But take note that it might happen also that when we deal about points on the coordinate plane or on the unit circle, we also talk about those points which are not considered to be perfect or not part of the special triangles definition.